Okay, so in this video, what I'm going to do is, rather than trying to find out a concentration, what I'm going to be doing in this video is trying to find out a volume from the concentration. And this is basically the results from a titration experiment. So the question says 18.8 centimeters cubed over 0.2 molar solution of nitric acid. So this is the volume of it, and this is the concentration. So that basically means, if I write it down, this basically means 0.2 moles per dm cubed. It's basically the same as this. 18.8 centimeters cubed of 0.2 molar solution of nitric acid HNO3 reacts with 0.5 molar, so that's basically like 0.5 moles per dm cubed, of lithium hydroxide solution. And the formula is given there, lithium LiOH. And so the first question, question A, says write a balanced equation for this reaction. So these are both strong. This is a strong acid and this is a strong alkali. So this reaction is gonna have a 1-to-1 molar ratio. So basically, what that means is for every 1 mole of HNO3, to neutralize it, we're gonna need 1 mole of lithium hydroxide. So the balanced equation for this would be, and I'll do different colors for the acid and the base. I'll use blue for the acid and I'll use green for the base. So HNO3 reacts with lithium hydroxide to produce, and obviously what would be produced when an acid and base reacts is a salt and water. So the salt produced in this situation would be lithium nitrate. So Li, actually I'll draw the Li in green since, yeah, LiNO3. And the water would be produced also. The water comes from here and here. So I'll just use light blue for that, H2, and the green O. There we go. So this is the balanced equation, since the one mole of HNO3 reacts with 1 mole of LiOH to produce 1 mole of lithium nitrate and 1 mole of H2O. Oh yeah, I forgot plus sign. Hold on. Yeah, plus. Yeah. Sorry. My throat feels strange. And so the next question says, calculate the number of moles of HNO3 present in the acid added. And to do this, we would need two values. We need the concentration and we'd need the volume. So we've been given calculate the number of moles of HNO3 present in the acid added. So this is the acid added, and this here is the volume, 18.8 centimeters cubed, and this is the concentration, 0.2 moles per dm cubed. And if you remember, the equation for working out a number of moles from a concentration and volume is number of moles, N, equals concentration multiplied by the volume. And if the volume is given in centimeters cubed, then we divide this by 1000, and it is given in centimeters cubed, so we do divide it by 1000. And so from this point, what we need to do is put our values in, which you've been given in the question, 18.8. So number of moles equals, well, put the concentration first since that's 0.2 multiplied by 18.8, and we divide this by 1000. And if you enter this into your calculator, you get 0.2 times 18.8 divided by 1000. You get 3.76 equals 3.76 times 10 to the power of minus 3, which is basically equal to, let me see, 0.00376 moles. So this is the answer, 0.00376 moles. And so if we move on to the next question, how many moles of lithium hydroxide were in the sample of the alkali? And if you've seen in my previous video, you notice that this is like very similar sort of question. It's basically asking you to look at the equation and figure out the molar ratio, and then use that and apply that to the question. And if we look at this particular equation, we can see that the molar ratio is just a 1-to-1 ratio. There's 1 mole of this reacting with 1 mole of this, and therefore we don't actually need to calculate much for this. We can tell that it's 1-to-1. So therefore the number of moles present of the LiOH is the same as the number of moles of the acid. So the answer is the same here as this. So number of moles equals 0.00376 moles. And so now let's move on to the last question. What volume of lithium hydroxide was required to neutralize the HNO3 solution? And so for this question, first let's look at what we already know. The question gives us the concentration of the base of the alkali, lithium hydroxide, and it's 0.45 moles per dm cubed. So let's just write that down. C equals 0.45 moles per dm cubed. And we've worked out the number of moles. N equals 0.00376. N equals 0.00376 moles. And so now we can use these two values in the equation. Number of moles equals concentration times volume. But for this question, we'd need to rearrange it. And if we rearrange this to make volume the subject, we need to divide the number of moles by the concentration. So we get that volume is equal to the number of moles divided by the concentration. And since all of our values here are in the standard units, moles per dm cubed and moles, we don't need to do any like dividing by 1000, multiplying by 1000 or anything. So now if we do this calculation, therefore the volume equals 0.00376 divided by 0.45, and that gives us an answer of 0.00376 divided by 0.45. This gives us an answer of 8.35 recurring. 8.355555556. So that would be let me just use a slightly different color here. 8.35. Actually, I'll round it up here to 3 significant figures. So 8.36 times 10 to the power of minus 3 dm cubed. And so if we put this in the non-standard form, it would be 0.00836 dm cubed. And so yeah, that looks about right. So that's how we would sort of tackle the question if we were given a concentration and trying to figure out the volume